Today we're going to talk about slope as a rate of change. Now you've dealt with rate of change for a long time in your lifetime, maybe not even known it before, but you're taking a trip before, say in a car. Let's say, for instance, you were to travel in a car and you went 120 miles and it took you 2 hours to do that. You've often thought of this as speed, which is the same thing as rate of change. In this case, 120 miles divided by 2 hours, you traveled at 60 miles per hour. I'm going to do a visual up here, geometric example, and let you see how it looks. So this time we're going to go for a walk. We're going to go in feet per second is how we're going to do it. And let's say we start out someplace, we haven't gone anywhere, so we're just going to start right here at the point 0, 0. One thing to take note of in this graph is your x-axis here is going to represent time. Your y-axis right here is going to represent the distance traveled. So let's say in your walk, in 5 seconds, you travel 20 feet. So in 5 seconds, you travel 20 feet. Now let's say you take a second journey. Once you get to this point here, let's decide you go for the next 5 seconds. So from 5 seconds over here to 10 seconds, and let's say you travel 10 more feet. So for 5 more seconds, you travel 10 feet here. So that point is going to be represented by the point time 10, distance 30. This point here we talked about it, the time was 5 seconds and the distance was 20. And let's see if we can go ahead and calculate the rate of change for each of these little segments of our trip. Now, right here we look here, how much time or how much distance did we travel over this first trip? Well, we went 20 feet. How long did it take us to do that? 5 seconds. So if we go 20 feet divided by 5 seconds, our speed, or in this case our rate of change, is going to be 4 feet per second. Let's see over this course of the second trip what our rate of change is going to be. Now this is a little different here because we'd already traveled 20 seconds, we already traveled 20 feet. Now we find ourselves traveling a total of 30 feet here. So in this case, how many feet have we really traveled? Well, if you said 10, you're correct. We started at 20 feet, we ended at 30 feet. So in this case, we traveled 10 feet. Now how long did it take us to do that? In this second point here, we'd already traveled 5 seconds. In this third point here, we finished at 10 seconds. So if you notice here, the net difference is took us 5 seconds, from 5 seconds to 10 seconds. Now in this example, what's our rate of change? What's our speed going to be? How many feet per second did we go? 10 divided by 5, it was 2 feet per second. Now, I want you to look at this graph closely and kind of analyze it. Could you just look at this very closely and say right off the bat what the faster speed was? Think about that for a second. One thing you should notice is in this case, because it's a steeper graph, this is going to have a greater rate of change. Again, slope is represented as a rate of change here. So this greater slope gives you a greater rate of change, gives you a greater speed. In this case, you know it's a little flatter, so it's going to have a lesser slope than this one right here. Now, let's say, friends, I don't want to analyze this graph over this first segment and the last segment. Let's say I just wanted to look at my graph from the beginning of it to where I finished. So I start right here and I finish up here. Maybe now, again, I want to look at the rate of change from the beginning to the end. So if we do that now, what's my average rate of change going to be? Once again, we started here. To get from here to here, we traveled 30 feet. How long did it take us to do that? Started here at time 0, finished at time 10. 10 seconds. 30 feet divided by 10 seconds, we get 3 feet per second. In this example, a true example of rate of change through this problem here, just taking a walk. Now, one thing I want you to take notice of here is that, again, slope can be looked at as a rate of change. Now, in this portion right here, I want to kind of isolate this second path right here. I'm going to stop right there.